Today we can see about optical fiber cable. If you go to a telephone exchange or some kind of switching network systems, you can see these kind of cables that are connected to the system. All these are optical cables, optical fiber cables. Now we can see the advantages of optical fiber cable. You can see the most important advantage is it has got electrical isolation. That is only one pair. Normally for electrical connections, a pair of cable is required. Here only one cable is required between the transmitter and receiver for proper transmission, and again that itself is do not have any electrical connection, so that is galvanic isolation is there. Then again the bandwidth of the optical fiber cable is very much higher than the electrical cables, metal cables. Then the low power loss, that is there will not be any loss, that is electromagnetic loss is electromagnetic radiation will not be there, and again there will not be any radiation due to radiation. There will not be any radiation loss due to heat. Then there will not be any interference. That is normally interference will picked by the cables, electrical cables. That is it will act as an antenna. And again the size of the cable is very lower. Optical fiber cable is very lower compared to the size of the electrical cable, and again the cost is also very lower. I think you might have studied about the copper loss, core loss, etc. Copper is having very high cost compared to this optical fiber cable. Normally optical fiber cable is very made up of plastic or glass, and it is cheaper than copper. Again the other advantage is the weight. The weight of the optical fiber cable is very lower, very thinner and lighter than the metal wires. Again security, that is optical fiber cables are very difficult to tap. If it is an electrical wire, you can just connect a cable to a metal wire to your this connection where between transmitter and receiver. You can tap the data, and again flexibility of optical fiber cables has greater tensile strength, and the copper or steel fiber has got lesser tensile strength compared to optical fiber cable. Again the cost of the material, that is the glass are plentiful unlike copper. That is the cost is very lesser. Cost of the optical fiber cable is lesser compared to the copper. So in addition to advantages, there are disadvantages are also there for optical fiber cable. One of the disadvantages, it is very difficult to splice. Splicing means if you are connecting from one cable to the other. Electrical connection means it is very easy to make, that is you can solder it or you can weld it, that kind of things, it is easy. But optical fiber connection means it is not easy. Special splicing devices are required. Again there is expensive to install. Installation of optical fiber is that is you want if it is an electrical system you can do it in the existing systems, but for optical fiber cables you want to require special systems. Again highly susceptible. Highly susceptible means it may break. That is compared to electrical connection, it is easy to break. And again suppose some building, it is installed in some building. If there is some maintenance in the building, that is there is a possibility to break the cable. Again it cannot be curved. That is if you are giving a curvature for this optical fiber cable, there will be a loss of transmission of light, and so that will reduce the signal transmission. These are the disadvantages of optical fiber cable. Then the next is the applications of optical fiber cable, and the most important applications is in the communication itself. That is you can use it for voice communication, that is telephony, data. That is data means internet, that kind of applications it can be used. Then the next one is the sensing. Sensing means suppose you want to sense the temperature, pressure, etc. in some remote locations, and you want to process it at another end. That is if you go to refineries, that kind of things you can see. So to send the data over these lines, long lines, you can use the optical fiber cable. and again it can be used for power delivery also. Power delivery means such as laser cutting and welding. It can be used that optical fiber cable can be used for optical laser cutting and welding. And again for illumination means you might have seen some kind of display systems. And again in the case of this keyhole surgery and that kind of things, that is the doctors use these optical fiber cables to illuminate inside our body, that is to see the organs and that kind of things. We will use the optical fiber cables. These are the applications of the optical fiber cable. The next one is the block diagram of the optical fiber link. You can see here there is a transmitter and a receiver. You can see a transmitter and a receiver. This is the transmitter receiver. And normally optical fiber system, we are transmitting light instead of electrical signal. We are transmitting light. So normally here also there will be repeaters will be there. That is signal will fade after some time. So there will be repeaters will be there between transmitter and receiver. And before transmission, so here we are converting the electrical signal into the light signal, and here again back from light to electrical. So optical detector. Normally optical detector will be a photodiode, that kind of things, and here this will be a laser diode. That is converting electrical signal to a light. We will use a laser diode, and here we will use a photodiode. So again before transmission we will modulate, that kind of things will be there. Before transmission we will use modulation, that is PAM, or always this will be a digital data transmission. In the case of optical fiber, normally it will be a digital data transmission. So we have seen some kind of digital data transmission, PCM, PAM, that kind of things we have seen. So we will convert the message or audio or video by using some modulator, that is a digital modulation techniques, and there will be a carrier source, that kind of things will be there, that as you have studied. And before converting it into light, we will do all these things in the transmitter part. And this is the channel. That is between suppose sometimes it may be between countries. There is optical fiber links are there between different countries. The name of link is CME to Southeast Asia, Western Europe, CME, Southeast Asia, Western Europe, that kind of things. Different between, so submarine cables are also there. So between these lines, there will be repeaters also will be there. Again, this is the receiver side. So we will use it by using a photodiode, then amplifier, processing. So between these lines we require only for transmission only one cable is required. But if it is an electrical line, we require a pair of cables for direct transmission. That is one of the advantage. And again we can have enough bandwidths. These things are the advantage. Then we can see how a optical fiber cable works. This is the structure of cross section of a optical fiber cable. There is this is the core. Core means a glass having higher refractive index, and here there is another material, glass or plastic, having higher refractive index. This blue line is the glass or plastic having higher refractive index. This is another material or same type of material having refractive index 1% lesser than this one. So normally there will be a refractive index change. So when there is a light tends to pass through this from a denser medium to a rarer medium, there will be a total internal refraction will take place. That is what is actually happening here. This is actually these things you might have studied in your optics classes or physics classes. So we are using the principle of total internal reflection in the case of this optical fiber. So we can see different types of fibers are there. This is known as a step index fiber, and this is known as a graded index fiber. This is step index fiber means the core will have, this is the A, this area is the core. The core will have same refractive index throughout this its area. Throughout this area it will have the same refractive index. But in the case of graded index fiber, the refractive index will be very higher at the center of the core, and as you are moving radially outwards, the refractive index will reduce in the core itself. And this area is known as cladding. Cladding refractive index will be always lesser than the core refractive index, and this is actually the case, the covering case. So here you can see the radial index and the refractive index. That is, you can see the refractive index will be higher. This is the refractive index, N will be higher, and here it is uniform in the core. And cladding will have a lesser refractive index. You can see that is the radius. This is the radius from the center. Refractive index will be lower. Here on y-axis, refractive index is there. X-axis the radial index. Here also on the y-axis, refractive index is there. X-axis radial distance. So here you can see here the refractive index will be higher maximum at the center, and here gradually reduces. And cladding, it will be uniform. So this is the structure of an optical fiber cable. So depending upon the construction of this optical fiber cable is classified into step index fiber and graded index fiber. Graded index means the refractive index will reduces gradually, and in the step index it will have a step change. That is why it is called a step index. Here it is there is a gradual reduction in the refractive index. That is why it is called graded index fiber. Now we can see how the light waves will pass through this optical fiber cable. This is the core. This green area is the core. This is the cladding, and this is the coating. So when the light will pass through this core, it will encounter a total internal reflection, and it will go through this core, and it will have multiple total internal reflection. And when it is passing through this core, there will be loss, and again there will be phase shift also will be there, loss as well as phase shift. Accordingly, different modes of propagation is also there. Different modes of propagation is there for this optical fiber cable. And here you can see there is an acceptance angle. That is, if you normally the electrical signal has to be converted into light before it is passing through this optical fiber cable. So this light has to be keep within this acceptance angle. Light means that normally it will be a laser diode to convert the electrical signal into light signal. So we will keep that laser diode here. So this laser diode will have some wavelength. Different laser diodes will have different wavelengths. So it has to be kept in this acceptance angle. If you are keeping the laser diode here, it will not be picked up by this optical fiber cable. So this is known as the acceptance angle. That is the angle in which we have to keep the maximum angle that can be picked up by this optical fiber cable, within which we have to keep our this thing laser diode.